Sketch the graphs of f dash of x equals x cubed plus 6x squared plus 9x and an approximation of the original graph f of x on the same set of axes. To start off this question, we're going to find when f dash of x, the derivative, is equal to 0. And the reason why we do that is that finds us the stationary points on the original graph. So that will give us the equation x cubed plus 6x squared plus 9x is equal to 0. And to solve this polynomial, we're going to do that by factorising and using the null factor law. So the first thing we can identify is that x is a common factor of each term, so we can take that out as a highest common factor, leaving behind x squared plus 6x plus 9, and that is still equal to 0. And now if you inspect that trinomial, you find that the factors of 9 that add up to 6 are positive 3 and positive 3, meaning it's a perfect squared of x plus 3 all squared, and that still equals 0. So using the null factor law, we find that x could equal 0, or we have x plus 3 could equal 0. Subtracting 3 from both sides of this equation gives x equals negative 3. So for f dash of x, it's going to be a cubic graph, and it's going to be a positive cubic, because this is a positive number in front of the x cubed term, and it's going to have a turning point at negative 3, and that's because it's a repeated factor, and it's going to have a regular x-intercept at x equals 0. So that means our cubic graph f dash of x will look something like this, and it will have x-intercepts at this point, which is minus 3, 0, and at 0, 0. So this is f dash of x, and it is the derivative of f of x. So that means whenever this graph has x-intercepts, or it equals 0, there'll be a stationary point on our original graph. So that means somewhere along this dotted line, and it's not an asymptote, there's going to be a stationary point. And the same with this line here, when x is equal to 0. So if we have a look at the value of the derivative around these stationary points, for the one at x equals negative 3, it goes negative, 0, and then negative again. So that means it's a stationary point of inflection. And at x equals 0, it goes negative, 0, positive, which makes it a local minimum. And we know that because it goes negative, 0, positive. And for the stationary point of inflection, if it goes negative, 0, negative, it's going to look like that. So that means on our original graph f of x, it's going to have a negative gradient, a 0 gradient, negative again, a turning point, and then it's going to head back up. So in purple, we've drawn a possible graph of f of x. One thing to note is that this purple graph could be translated up or down, and it would still have the same derivative function. And you'll learn more about that when we do our unit on anti-differentiation.